Hello, this is EdMiller with StocksPoker.com, and I have a new set of videos for you starting today. And this set is about microstakes, no-limit hand reading. It's not just for microstakes, but it's aimed at microstakes players, and some of the ideas and principles are going to be, I would say, sort of more specific to microstakes, but it's a good introduction to no limit hand reading in general. And it's going to be a multi-part series, and basically there's a ton of material I have, and I'm just going to I'm not going to worry too much about how I break it up. I'm just going to keep going and give a nice solid intro here, and then the next part is going to pick up where we left off, and then the final part, hopefully we're going to get some hand reading problems in for you. So I'm looking at a 3-part series at the moment, and hopefully it stays that way. So let's get started. So there's, as I see it, there's basically two major aspects of hand reading, and I call the first one combinatorial hand reading, and then the second one is psychological hand reading. And I'll tell you what I mean. So combinatorial hand reading is sort of just based in math. And the idea is that certain hands are just more likely to be dealt than other hands. And so knowing that and understanding that actually goes a long way toward reading hands. A lot of hand reading, people on TV sort of talk about hand reading like it's some voodoo process, like seeing into souls and blah, 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 blah. But the cornerstone of hand reading is really in math, is that this hand will be dealt often and this hand will be dealt rarely. And so from that basic prior probabilistic framework, you can really deduce a lot about what your opponent is likely to hold. So that's combinatorial hand reading. And then the second type of hand reading is I would say equally important, and that's psychological hand reading. And that basically is, combinatorial hand reading is sort of the basis. It's sort of the foundation, that mathematical foundation that underlies everything in poker. And then psychological hand reading is where you overlay your opponent's observations about your opponent on top of that, and you try to intersect those two things to come up with a good idea for what your opponent has. So that's the two basic aspects. I would say that psychological hand reading, I would break it down further into two other categories. The first category is what your opponent's attitude toward their hand is, and that includes their emotional state. Basically trying to figure out, based on what your opponent is doing and how your opponent's behaving, how they feel about their hand, what they're trying to accomplish, and maybe, just how they feel in general. So that's the first part. And then the second part is multi-level thinking. And this is a concept most of you are probably familiar with, but maybe haven't really thought, gone through logically and step by step and thought exactly the implications of what multi-level thinking has on hand reading. Because the thing is about multi-level thinking is you have to get into your opponent's brain and try to figure out what level they're thinking on it. It does no good, so by multi-level thinking I mean, you look at your hand, is your hand good or not? That's level 1. Right? Level 2 is you look at what your opponent's doing and you're saying, does your opponent have a good hand or not? Or is it better than mine? Or what kind of hand is it? So that's level 2. Level 3 is, based on how I'm behaving, how is my opponent likely to interpret my hand strength? That's level 3. And then level 4 is, my opponent knows that I'm reading his hand, and what do I think he thinks I'm going to put him on? So that's sort of the game, and then that game can go on forever. In practice, it doesn't go on forever, though. In practice, your opponent is thinking on a certain level. Your opponent is making their decisions, has a certain attitude toward their hand because of something, and you have to figure out what that something is. Is it just because they think, I have a good hand, let's put some money in? Is it because they think, my opponent looks weak, let me put some money in? Is it because they think, my opponent's going to think I look this way, so let's do the opposite? That kind of thing. So that's how multi-level thinking plays into hand reading. You have to come up with that. So those are the basic ideas. So let's first talk about combinatorial hand reading, because I think a lot of people don't fully appreciate exactly how important combinatorial hand reading is in all hand reading decisions. So let's start at the basics. So combinations are really at the heart of hand reading, and some hands are more likely than others just because it's easier to produce them. And the first way to figure out how easy or hard it is to produce a hand is to look at the preflop combinations. So there's 6 ways to make any pair. And by 6 ways, I mean that there's 4 cards in the deck of any given rank. And then there's 6 ways to take those 4 cards and make 2-card hands out of them. So, for example, for a pair of aces, there's ace of spades, ace of hearts, ace of spades, ace of diamonds, ace of spades, ace of clubs, ace of hearts, ace of diamonds, ace of hearts, ace of clubs, and ace of diamonds, ace of clubs. So those are the 6 ways to make any pair of aces. Please forgive me if you already know this. Don't worry, the whole video is the sort of difficulty level ramps up, and if you don't know this, great, you are starting in the perfect place. Anyway, so there's 6 ways to make a pair. So likewise, there's 4 ways to make any given suited hand, like ace-king suited. You can have ace-king suited of spades, hearts, diamonds, or clubs. And there's 12 ways to make any offsuit hand. So ace-king offsuit, there's 12 different combinations of that. So just right off, if you look at that, first of all, non-paired hands are going to be a lot more common than paired hands. And furthermore, any given non-paired hand is going to be more likely than any given paired hand. So, if you think your opponent has either ace-king or aces, ace-king is the more likely hand by far. And if you think your opponent has aces, kings, or ace-king, ace-king is still more likely than either of the 2 pairs, because there's only 6 ways to make aces, 6 ways to make kings, and there are 16 total ways to make ace-kings. So the 12 ways to make the pairs are less than the 16 ways to make the ace-king. So that's a really important hand-reading principle. And it comes into play all the time. So those are really basic critical numbers, and you should really sort of just pound those into your head, just until they become second nature. Because they really are super important. Now, once you see a flop, those numbers, they actually change quite a bit because of the board card. So let's look at some of the post-flop combinations. Okay, so let's look at those post-flop combinations. So, first of all, there's 12 ways to make top pair with any specific kicker. So, for example, to have ace-king, if the flop comes king-7 deuce, there's 12 different ways to have ace-king. Now, notice that that's lower than the 16 ways to have ace-king pre-flop, and the reason is that one of the kings isn't available for ace-king. The king is on the board instead. So likewise, there's 9 specific ways to make 2 pair, because one of the cards of each rank are eliminated, so it's 3 times 3 is basically how you figure that out. There's only 3 ways to make a set, because there were 6 ways to make a pair, but then when you take one of the cards out, there's only 3 possible combinations left. And there's 6 ways to make an overpair, because that's the same as the original preflop. So, so first of all, notice the relationships in these numbers. This is basically the reason why sets are so uncommon, and why they're so valuable. Because there's, if the board comes king-7 deuce, and and your opponent seems strong, and you think they either have a set or ace-king maybe, then even though there's 3 ways to have a set, 3 different hands, kings, 7s, and deuces, there's only 9 combos of set, because there's only 3 ways to make each set. So there's 9 total combos of set, whereas there's 12 combos of ace-king. So even though you might think that a set would be more common, your opponent is actually going to be more likely to have ace-king. So if you have something like pocket deuces, so you have a set, and your opponent acts really strong, you're actually a big favorite in the hand, even if you think your opponent would only act that strongly with ace-king, pocket kings, or pocket sevens. And if you throw pocket aces in there, you're even better off. So that's why sets are so powerful, even bottom set, is just because it's so rare to make another set that your opponent will act and behave strongly with hands that are weaker than a set, just based on those basic probabilities. So that's sort of the first observation. So this can lead to some interesting conclusions. Let's look at another example. So now instead of pocket deuces on that king 7 deuce flop, you have ace king. And you think, your opponent maybe re-raised pre-flop or something, and for whatever reason you think your opponent has one of 4 hands. You think your opponent has pocket aces, pocket kings, ace king, or king queen. And you want to know, are you the favorite in the hand? If you get all the money in, say you think your opponent will get all the money in with any of those hands. If you get all the money in, are you going to be a favorite? So let's see how to analyze this. So there's 2 hands you lose to, pocket aces and pocket kings. And furthermore, you're drawing nearly dead against the pocket. You're actually drawing very, very slim against either of those hands. And then ace-king you obviously chop with. And king-queen you obviously has only 3 outs against you. So you're way behind against 2 hands. Against the aces, you're drawing to 2 outs, to the 2 more kings. And against kings, you're basically drawing dead. You need running aces to pull that one out. So, and then you're going to chop against ace-king, and you're drawing to 3 outs against king-queen. So it might at first glance seem like you are sort of actually in trouble against this range, because again, when you have your opponent, they have 3 outs. When your opponent has you have 2 or 0 outs, essentially 0. And so it seems like you're, there's more hands you're behind against. You're worse behind against those hands, and you're basically just hoping for one hand. But let's do the combinational analysis and see how it works out. So there's 6 ways your opponent can have pocket aces. There's only 1 way your opponent can have pocket kings. So yes, even though you're a huge underdog against pocket kings, it's also going to be a very, very uncommon that your opponent shows up with that hand. There's 6 ways your opponent can have ace king, and again, the reason there's only 6 is because you have one of the aces and one of the kings, and one of the kings is on board. So there's only 2 kings left and 3 aces left. That's why there's 6 ways. Sorry, there's only 3 ways for your opponent to have pocket aces. I don't know. I had sort of a brain fart. And the reason why your opponent can have aces only 3 ways is again because you have one of the aces. And then for your opponent to have king queen, there are 8 ways for that, because 2 of the kings are left and all 4 queens. So your opponent can have aces 3 ways, kings 1 way, ace king 6 ways, and king queen 8 ways. So let's go back. So we said you were in real trouble against aces and kings, chopping against ace king, and doing well against king queen. So even though at first glance it looked like you might be in trouble, you're actually in a pretty good situation here, because your opponent is twice as likely to have king queen as he is to have either aces or kings. And that's the key point. So it turns out, if you run the numbers, that your ace-king is actually a 57-43 favorite over your opponent's range. So that is, again, a very basic hand reading exercise, but it's really important. And it's really important in all your hand reading. Whenever you try to do hand reading, you really have to think, you can't just say, oh, that looks like a set. You have to take into account how likely everything is, overall. Okay, so I want to jump ahead a little bit just to show you guys an application of combinational hand reading, or combinatorial hand reading, rather, that I use pretty often. That's almost pure combinations, and I use combinatorial hand reading pretty often to try to pick off bluffs, or to make so-called hero calls on the river. And here's the basic principle. If my opponent plays a hand where the number of hands that I think that they would play that way, the number of legitimate hands that I think that they would reasonably play that way, if the combinations of those hands are very, very, very few, then often that means that their chance of bluffing is a lot higher. And here's the basic idea. Say your opponent plays a hand in a very peculiar way, and the only hand that makes sense for them is 9-8 of clubs. You go through the hand, and they called here, and they raised there, and they bet big on the river, whatever, and you go through and you say, wow, what hands would they do all those three things with reasonably? And you say, wow, the only hand that really, they flopped a straight draw, and then a diamond came, and, and blah, 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 blah. And you say, wow, that's the only hand that makes sense. Well, whenever something like that is the case, then the chance that your opponent is bluffing, or the chance that this bet is a bluff, is much, much higher. And the reason is basic, and it's rooted in math. It's basically an application of a probabilistic theorem called Bayes' theorem, which says that, say your opponent will only, three-barrel bluff, or only launch a big bluff, 2% of the time. Well, that's not very often, but if you look at any individual bet, you can't say, well, that bet is going to be a bluff 2% of the time, because if you say that they'll bluff with a random hand 2% of the time, but that they can only have this specific hand, because there's only one combo of it, one time in 100, say, then there's actually a 2/3 chance that they're bluffing. So let's go through that again. So say your opponent, this is sort of a simplification, but this will give you the basic idea. Your opponent will bluff a random hand 2% of the time. The hand plays out. It plays out in a way that's peculiar, and that only 1% of your opponent's total combinations fit the way your opponent plays the hand. But there's still that 2% chance that they're bluffing. Well, overall, given that your opponent has played this hand this way, it's actually more likely that they're bluffing than that they actually have this even rarer hand. So that's the basic idea. And it comes down to combinations. If there's a bunch of combinations that your opponent could have that fits their play, then, maybe it's not bluffing, or less likely they're bluffing. But if there's only a very small number of hands that makes sense that your opponent would play that way, or if you think it's very unlikely that your opponent would play legitimate hands the way they played it, then the chance that they're bluffing goes way up, even if they do make a pretty big bet. So here's a hand example, just to sort of whet your appetite, of a hand that I made a pretty big call on the river, and I used this type of analysis to make that call. So I have Queen 8 offsuit. My opponent is I would say a pretty bad player, and so my opponent limps in the small blind, and I do what I often do, which is to raise in the big blind. I have Queen 8 offsuit. It's a perfectly reasonable hand for a blind battle. I'm going to have position. My opponent's not very good. I'm happy to play the hand. Flop comes King Queen 9. So I have a pair of queens. It's a pretty good hand, but it's a flop that's going to hit. Given that my opponent called the raise, I would say that my opponent's range in general is going to be better than if they didn't call the raise. So this flop is going to hit my opponent's range fairly well. So I go ahead, and I don't want to. This opponent is pretty aggressive. I would say almost crazy aggressive. So what I do is my opponent checks and I check, and my check has two purposes. One is it controls the pot. I don't think I'm going to get a ton of value out of my queen if I play it bet, bet, bet. And my opponent is fairly bluffy, so I checked to sort of try to induce my opponent into betting into me with nothing. So a deuce rolls off on the turn. I like this card. My opponent checks again, and I check again for the same reason. Here, I think there's a good chance my opponent has nothing, and I want to give him a shot to bluff into me on the river, because I think if I bet here, I'm gonna just pick up the pot often, and I want to try to get a little bit of value out of my hand. So the river comes a perfect card for me. Really, is a king, and unfortunately, my opponent bets again. So now I think there's an excellent chance I have the best hand. So I go ahead and make a value bet. Hope I get called by a 9, small pair, something like that, a deuce maybe, ace high, something like that. But instead, my opponent decides to check raise me to $45. And here I thought a little bit about it, but then I ended up calling. And the reason I called was I said, well, what legitimate hands would my opponent play this way? So what is my opponent representing with this check raise? Well, representing Jack 10 maybe, a straight, maybe a hand like Ace King, King Queen, maybe a hand like, a full house. This is a strong check raise here. My opponent is really representing a whole lot of strength. And the thing is that I really couldn't give my opponent credit for any of those hands, because my opponent checked 3 times. If my opponent had, say, Jack 10, I could see him checking once. I could see him checking twice. But then by the time I check behind on the turn, I'm showing a lot of weakness, and I would expect him to bet a hand like Jack 10. I would certainly expect him to bet a king before the river, or at least on the river. And so I went through the combinations of hands that my opponent could legitimately play this way, and I basically came up empty. I said, all the hands that my opponent is representing now didn't make any sense for him to play before. So I came up with essentially 0 legitimate combinations. Now, you can never have 0. Sometimes your opponent's going to play in a way that's unpredictable, that you don't expect. But I said, chance of legitimate hand here is very small. Now, given that, and given the fact that my opponent in fact has raised and is representing a legitimate hand, I thought there was a much greater than average chance that he was bluffing. So I called, and sure enough, he had nothing and was just trying to push me off the pot. So that's an example of where I used combinational hand reading. In addition, I used some psychology. I said, how would my opponent play their hands, play these hands. So that's why I say I'm jumping ahead a little bit. But the root of it was basically just the basic math that I said my opponent is bluffy. My opponent is going to decide to bluff a certain percentage of the time, just because that's what he does. And the way he's played this hand, I couldn't come up with enough legitimate combinations, or rather, I came up with a relatively small number of legitimate combinations for his hand, so the overall chance that he was bluffing in this particular situation was much greater. So going back to the example from before where we had ace-king and our opponent had aces, kings, ace-king, or king-queen, I came up with the conclusion. We went through the number of ways that my opponent could have aces, kings, ace-king, or king-queen. And then I sort of jumped to a conclusion and said that ace-king was a 57-43 favorite over the range. And you might wonder how I got that. Basically, the mathematical way to come up with that is first you come up with the number of combos of each of your opponent's possible hands, and then you calculate the equity your hand has against those hands separately. So how does ace-king do against aces? How does ace-king do against kings? How does ace-king do against ace-king? How does ace-king do against king-queen? You come up with those percentages, and then you weight those percentages by the number of combinations of each hand that's possible. And then once you do that, you come up with the overall number of 57-43 favorite over the range. So there's some software tools that actually do that for you. And these software tools are really, I would say, a very fundamental, I use them all the time, tool for working on your hand reading and for working on your game outside your play. And so those tools are, you've probably heard of them before, but here I'm going to link to them again because they're super important. The first tool is Poker Stove. It's a and you can find it at pokerstove.com. And the second tool is actually on my website, and it does much the same thing. And the URL for it is here listed in the slide. And basically, either piece of software will solve these problems for you. PokerStove is a client-side application, so you have to download it to your computer. It runs on Windows, and so forth. Whereas the tool on my website is web-based, so you don't have to download anything to your computer. You can just type in your problem, and it'll solve it right on the website. The upside about PokerStove has a sort of graphical interface that'll help you select hands for range, whereas with the web tool, you have to type your range out by hand, and there's sort of a little syntax for denoting your range. So those are the differences. I suggest you use both. Get familiar with both, and some are, sometimes if you just want to run a quick calculation, you might want to just go to the website. If you want to do a lot of heavy-duty calculations, you might want to use PokerStove. Anyway, those are the tools that you can use to solve these problems. Alright, now I want to talk a little bit about straights and flushes. And the thing about straights and flushes is, generally, they're uncommon hands, they're worth a lot, they win a lot of big pots and stuff like that. But the thing to understand is what makes them uncommon is not that, they're uncommon coming out of the gate. In other words, if it's before the flop, no cards are out, you're playing, maybe if you're playing 2 or 3 players, or any given opponent is going to be very unlikely on that hand to make a straight or flush. However, once the flop comes out, and there's 3 cards of a suit on board, or there's 3 cards to a straight on board, now it's actually reasonably likely for somebody to have a straight or flush. So, and I want to sort of put a mathematical number on exactly how reasonably likely it is. The reason I'm going through this is a lot of people will say, when the 3 diamonds come out, and your opponent is strong, people will say, well, what are the chances my opponent flopped a flush? They're not good. Or maybe 10-9-8 comes out, and you're like, what are the chances my opponent flopped a straight? It's, that's, 1 in 100 that he flopped a straight. And it's actually not even close. It's actually, your opponent is actually fairly likely to have one of those hands. So let's go see exactly how likely. So with straights here, let's talk about straights. So if it's a 0 gap straight board, like 10-9-8, there's no gaps in the board. There's 48 ways to make a straight. You could have Queen Jack, one of 16 ways, Jack 7, one of 16 ways, and 7-6, one of 16 ways. For a 1 gap straight, like 10-8-7, where the 9 is missing, then there's only 32 ways, because you need the 9, so it's Jack 9 or 9-6. And then with a 2 gap straight, like 10-7-6 or 10-8-6 or something like that, there's only 16 ways, because your opponent has to have those 2 exact cards, 8-9 in this example, and they can have that 16 ways. So, so that's the basic. And actually, that's a lot of ways. Like, if you compare, like, say the board comes 10-9-8, that's 48 ways to make a straight. In the above example, we were talking about 3 ways to have aces, 1 way to have ace-king, 8 ways to have king-queen, that sort of thing. So actually, 48 ways to have a straight is actually, quite a number of ways to make a straight. And that's why it actually isn't so uncommon. Now, looking at flushes, if there's 3 flush cards on board, and you don't have any of those cards, any of the suit, there's 45 ways your opponent can have a flush. There's 10 remaining flush cards. Your opponent has to choose 2 ways of that, and it works out that there's 45 different combinations. So there's a lot of combinations of that too. There's almost as many flush possibilities when there's 3 flush cards out as there are straight possibilities when the board comes 10-9-8. So, so the takeaway from looking at this is actually that when the board is 3 flush or 3 straight, those flushes and straights are actually surprisingly common. Sort of the hard part, if we say, well, it's hard to make a flush or hard to make a straight, actually most of the hard part is sort of done already once those 3 flush cards come out on board, or once the 3 straight cards come out on board. And it's not as hard, to complete that hand with the two cards. So let's dig a little more in depth into that and see exactly what I'm talking about. So say the board comes 10-6 deuce, and it's all one suit. And let's talk about some of the hands, and your opponent seems to like their hand. They're betting, they bet, you make a big bet, or maybe they raise or something. So for some reason, your opponent has played the hand in a way that you think it's likely they have something pretty decent. So let's go through the decent things they could have. They could have ace-10, and they could have that one of 12 ways. They could have pocket jacks, one of 6 ways. Pocket queens, one of 6 ways. Pocket kings, one of 6 ways. Pocket aces, one of 6 ways. They could have a set, pocket 10s, pocket 6s, or pocket deuces, 3 ways each. Let's say that 10-6, 6 deuce, and 10 deuce are relatively unlikely. So let's just skip those. Now you wouldn't actually skip those. You'd assign them a small percentage. But let's just skip those for the sake of the argument here. And then let's say that your opponent could have a flush, one of 45 ways. Now, I did play some games here because I don't think, Jack 3 suited, if we're going to discount 10 deuce, maybe we should discount Jack 3 suited too, but, let's, this is just the basic, simple, back of the envelope analysis. If you look at these hands that I've put on the slide here, there's actually 45 ways that your opponent can have less than a flush, and then 45 ways they can have a flush. So if for some reason this were you thought were your opponent's range, and I, as I said before, it's probably simplified, and it's unlikely your opponent's range would look exactly like this, but if your opponent is showing a lot of strength on a flush board, in this case, it's actually 50-50 whether your opponent has a flush. So now, it's pretty common. I mean, it's definitely not, even if you adjust the numbers a little bit so that the bad, whatevers, you're still going to see a flush very often. So let's go ahead and talk about how to adjust those numbers for the action. So first, let's look at the pre-flop action. Obviously, if the person, if your opponent re-raised pre-flop, then, all of your overpair ways are going to stay, but a lot of the flush ways, like, 9-3 suited, are going to go way down in likelihood. So now the sort of less than a flush option is going to be a big favorite. But, say your opponent checked in the big blind, now aces through 10s go way down in likelihood because they might have raised those pre-flop. But you have to add back in 10-6, 10 deuce, and 6 deuce, and those make up for it because there's 27 ways to have aces through 10s, and there's actually 27 ways, 9 each for each of the 2 pair combos. So those sort of, let's cancel those out. And so, again, your flush chance is 50-50. If your opponent checks in the big blind, and the flop comes 10-6 deuce, all of one suit, and your opponent likes the flop, there's a pretty good chance your opponent actually flopped the flush. Now, say you have a flush. There's actually fewer flush cards out now. And in fact, there's only 28 ways left for your opponent to flop a flush. Because if you take 2 of the cards out, there's fewer ways. So, let's say you have 4-3 suited in the small blind, and your opponent checks in the big blind. You call, and your opponent checks, and the flop comes 10-6 deuce, all of your suit. Now, you're a favorite to have the best hand because the flush is less likely, but some of your opponent's hands that you beat have outs against you, whereas if you're against a flush, you're going to be all but drawing dead. So your equity in that situation is, let's take a look, at this slide. So you have 4-3 suited, flop comes 10-6 deuce, all of your suit. Let's say your opponent has ace-10, 12 ways, has pocket 6s 3 ways, pocket deuces 3 ways, 10-6 9 ways, 10 deuce 9 ways, 6 deuce 9 ways, and a flush 28 ways. And slightly fewer if you count ace-king suited, ace-queen suited, so far as raising hands. It's less likely that your opponent's going to have a flush. But say that's the range. Even though you flopped the flush, you're actually only a 52-48 favorite over that range. So you might think, wow, I flopped the flush, this is a great hand for me. But it turns out that if you get action, you're really only a marginal favorite. Now, you're also going to get action from, like, the lone ace of diamonds, too. Like, if your opponent has ace of diamonds, 7 of hearts, you're going to get action from that hand, too. But your opponent, depending, may or may not put all the money in and so forth. So, bottom line is that if you flop a tiny flush and your opponent, because of the pre-flop action, could have any of those suited hands, either because they're really loose or because they check the big blind or something, you're actually not a pretty big favorite because your opponent is actually fairly likely to have a flush themselves. So that's the basic idea behind combinatorial hand reading. Again, combinatorial hand reading is usually not something you do by itself. You use it in conjunction with psychological hand reading. And the next part, I will start to talk about psychological hand reading, and then we will, at that point, really begin making some reads. But just to finish off this video, I have a couple of problems, and let's get to them. So the first problem is you have pocket threes, and the final board is ace, queen, 3, jack, 4. And there's no possible flush on board. How many total hand combinations beat you? So there's two possible straights, king 10 and 5 deuce, and there's 16 ways to make each of those straights, so there's 32 total combos of straight. There's also 4 sets that beat you, aces, queens, jacks, and 4s. There's 3 ways to make each set for 12 combos total of set. So there's 32 combos of straight and 12 combos of set, so there's 44 total combos that beat you. Okay, here's the next problem. So again, you have pocket threes and the same board, ace, queen, 3, jack, 4, no possible flush. Now the question is, how many hand combos do you beat that make a pair of aces or better? So this one involves a little bit more math work. So basically we're talking about, you have a set, you have the worst set. So the hands you beat are going to be 2 pair and top pair. So how many different ways of each? Well, there's 10 different 2 pairs, 2 pair hands. You can verify that yourself if you count. Now 4 of those 10 are going to involve threes, and so therefore you're only going to be able to make them 3 ways. For instance, ace 3, there's 3 aces out, but there's only 1 3 left. So there's only 3 ways to make ace 3. Likewise for all the other 3s. For the other 6 2-pair hands, there's 9 ways to make them. So in total, to get 2-pair hands, there's 9 times 6, or 54, plus 3 times 4, or 12. So 54 plus 12, or 66 total total ways to make 2-pair. Now, how many ways are there to make a top pair of aces? Well, there for each of the hands, like say ace king, ace jack, sorry, not ace jack, ace 10, ace 9, so forth. There's 12 ways to make it. You know, there's 3 aces and there's 4 of whatever the kicker is. So there's 12 ways. There's 12 combos for each of the top pairs, and then you can make top pairs with any of 8 kickers because there's 5 board cards, 13 total ranks. So 13 minus 5 is 8. There's 8 ranks that aren't on board, which means there's 8 different kickers you can have for your pair of aces. So there's 12 ways to make each top pair times 8 possible kickers, or 96 ways. So the total number of combinations of hands you have are the 66 possible 2-pair hands and the 96 possible top pair hands, for a total of 162 combos. Alright, last question. So you have pocket threes again, but this time the board is ace, 7, 3, 6, 4. So you still have a set. Now the question is, how many hand combos now beat you? Well, your situation just got a lot worse here because there's a 1-card straight on board. Any 5 is going to make a straight. So, and furthermore, you're going to need a 5 to make a straight. There's no other hand that makes a straight that doesn't include a 5. So, first of all, let's go for the sets, because that's the easy one. So there's 4 sets, again, that still beat you. So that's 12 ways. 3 ways per set times 4 sets is 12 ways your opponent can have a set that beats you. So now let's look at the straights. So any 5 beats you, which means how many ways are there to have a hand with a 5 in it? Well, so there's 5 cards on board. There's 52 cards in the deck. 5 cards are on board. 2 cards are in your hand. So that's 45 cards left. So now if we choose one of those cards to be a 5, there's 44 cards remaining. So there's 44 different ways to make a straight with any given 5. Like say I have the 5 of clubs. There's 44 possible side cards for that 5 of clubs. Now, I don't need the 5 of clubs to make a straight. Any 5 will make a straight, so I have to multiply that 44 times 4. So the number of ways you can make a straight is going to be 44 times 4. The problem with that is that I've now counted each pair of 5s twice. I said 5 of clubs can be with the 5 of diamonds, and then when I chose the 5 of diamonds, I said that can be with the 5 of clubs. So I've counted that pair twice. So I have to subtract out all those pairs of 5s. There's 6 ways to make a pair of 5s. I've double counted each one, so I have to subtract 6. So the total number of combos to make a straight with any 5 is going to be 44 possible with each 5 times the 4 5s minus 6 to undouble count each pair. So that makes 170 total possibilities that include a 5, which means that the total number of combinations is 182. So I hope you've enjoyed this video on combinational hand reading, and the next installment, there's going to be several parts. It looks like, actually, I said at the beginning there might be 3 parts. Actually, there might be 4, 3 or 4. It's a big topic, and I still have a lot more to talk about. So look forward to the next video, and the next video will be a little bit less mathy and a little bit more applied. So I'm excited for that one, and I'll see you next time.